This is Climate on the Edge, where we explore the frontier of climate interventions and dive into the bold ideas that could shape our planet's future. And I'm Susan Sue.
So you're saying 2% of aviation moving a couple thousand feet up or down strikes out 2% of anthropogenic climate warming? That can't be real.
I talk to people who think and do and build climate-related solutions all the livelong day. And it has not come up across all these years. So I think that's really shocking.
This is just a checkbox in an air traffic management software. When this is all done, nobody should even know it's happening.
What has been the most surprising finding in your Contrails research? Sustainable aviation fuel, carbon removal, taxes on private jets. These are all different solutions proposed for the stubbornly hard to abate emissions from aviation. While they will all be needed to fully decarbonizing this sector, a rash of new research is showing that a potentially simpler technique, changing flight paths, might help defray a large fraction of the warming from aviation. In fact, roughly 10% of global flights, which is actually not 90%, are responsible for 1 to 2% of all warming each year. Why is this? Contrails, those long streams of vapor that appear behind some planes, cause a significant amount of heat to be trapped in the atmosphere in the short term. Since only a small fraction of flights actually produce those contrails, airlines, researchers, and federal agencies are now looking at ways to reroute planes and make other changes so that fewer flights will have this warming effect. Contrails account for an estimated 35% of aviation's total warming effect. So even the ambitious goal of eliminating them does not fully decarbonize aviation. However, as other solutions are still being developed, reducing contrails offers a very rare and time-sensitive opportunity for a hard-to-abate industry to reduce its climate impact in the very, very short term. Today, I speak with one of the leading researchers on this subject, Marc Shapiro of Breakthrough Energy. Breakthrough is the Bill Gates founded organization working to further climate solutions through research, investment, and philanthropy. Prior to Breakthrough Energy, Marc was an applied scientist and entrepreneur across a range of efforts encompassing fluid mechanics and geospatial analytics. And in 2020, he started a company to develop geospatial data analysis for climate mitigation and adaptation. Today, Marc is Breakthrough's director of Contrails. Marc and his team work in an applied science capacity, meaning they take fundamental research on atmospheric science, clouds, and contrail formation and behavior to inform solutions that airlines can put into practice to reduce their non-CO2 aviation emissions. Marc's work has been all over the Contrails news lately because he and his team, in conjunction with American Airlines and researchers from Google, recently published major findings from their Contrails work. Their paper, titled Feasibility of Contrail Avoidance in Commercial Flight Planning Systems, an Operational Analysis, shows that we could get enormous bang for our buck with contrails mitigation, meaning a small increase in fuel cost and volume could yield a 73% reduction in contrail-caused warming. What was also notable about this research is that its analysis was conducted against data from 85,000 real flights flown in 2 separate months in 2023 and 2024, whereas all previous contrails research work had been done on flight simulations. Now, just to clarify, that's not to say these real flights were actually diverted to avoid contrails, but that their real flight paths and schedules were used in the analysis. Still, this is incredibly important because it tells us that we could apply flight rerouting techniques to flights like these and dramatically reduce the immediate warming effects coming from contrails. And contrails are a quiet cause of meaningful warming that's often overlooked by those outside of aviation. By some measures, contrails are causing about 2% of all anthropogenic warming, or about 1/10 of a degree Fahrenheit of warming, which may not sound like a lot until you realize that every fraction of a degree affects the stability of Earth and ocean systems, and that 2% of total human-caused warming is on par with estimated emissions from the entire maritime shipping industry, which just on its own has gotten a lot more attention, for example, from the climate mitigation community than contrails have. Now, the reason I wanted to have Mark on the show is because I believe his work is some of the most important and reasonable and timely climate work out there. And I also love a good counter narrative to the idea that software and data can't solve a physics and behavior problem like climate change. Mark, welcome to the show.
Thanks. I'm excited to be here.
So, Mark, you are doing this incredible work at Breakthrough Energy, and you were seeing your career when you came into it already. You've been doing a lot of things across applied science and geospatial data already. What was your personal climate aha moment that drew you to the specific challenge of contrails? Why are you here?
Yeah, so I had just started essentially a consulting company to look into data solutions for climate. And I was approached by an old colleague with this topic of contrails. I had never heard of contrail climate impacts before that moment. And he was starting a new R&D organization called Orca Sciences, focused on unresearched opportunities in the climate space. And he said, "Can you take a look at this and let me know what you think?" This was in 2021, and I only had to read a few literature publications before I was really excited to dig deeper into the topic. The first real publication that got through to me was Roger Teo's paper in 2020. It did a study of Japanese airspace that showed diversions of less than 2,000 feet up or down could have a theoretical reduction of 60% of contrail warming. And that contrail warming as a whole could be as high as 2% of anthropogenic forcing. So I just multiplied the two numbers and realized, okay, so you're saying 2% of aviation moving a couple thousand feet up or down strikes out 2% of anthropogenic climate warming. That can't be real. And I think a lot of people have that same experience when they first hear about this. It sounds too good to be true. And in truth, it is hard. There's a reason that we're not already mitigating this impact. But the opportunity is the same as when I first read it. It's a very exciting opportunity. And so we got in touch with Mark Stetler, the PI on that study, and have started working on it right away.
Now, how did that lead you to the Contrails team or this title of director of Contrails, just overall at Breakthrough?
Yeah, so I started as a one-man research group in 2021, just looking into the topic, again, collaborating with Mark Stetler and Roger Teo of that paper. And so we started considering the idea of a commercial entity. It seemed like contrail mitigation was something that was ready to be commercialized. But very quickly looking into the topic, talking with Mark and a lot of other people that are involved with contrail research, it was clear that there were a lot of uncertainties both in the scientific side and in the implementation side. So we'll talk more about this later, but the uncertainty on the science side was just being able to quantify which flights should be mitigated and how much should they be intervened, because there is a cost to trying to get rid of contrails. You have to add some CO2 in fuel on the plane. And we were lucky at the time, we were able to pivot from considering the idea of a commercial enterprise and move into being more of a nonprofit applied sciences group that its main goal is to just accelerate the research to the point that it can be implemented if the opportunity can be realized. And so we worked at Orca Sciences for 2 years on the topic and slowly built a team of 3 research scientists. At which point we got promoted to being part of Breakthrough Energy as a special project to continue our research and grow our team.
So, Mark, in this 2 years, that initial 2 years that you were at Orcus, I'm curious, like when you said when you read the Japanese paper, it was like this wait, how can this be? How can we get so much bang for our buck? This is too good to be true. I'm curious in that first 2 years of the research that you did there with that initial small team, what about it, about your original hypothesis proved to be true? And what were some of the things that you were ultimately mistaken about?
So our original hypothesis was in many ways has remained unchanged, which is to say that we believe contrails are just meteorological phenomena. So they're just weather. And the aviation system knows how to work with weather data. Obviously, planes fly around thunderstorms, they fly through regions of icing, they avoid regions of turbulence. So we see contrails as just another criteria that gets built into the aviation planning system. And I think that has remained unchanged, and we only feel more strongly that the implementation path will follow that road. Early on, we expected the uncertainty of upper atmospheric forecasts to be lower than it actually is. So, one of the main challenges, the reason this isn't done already, is that weather forecasts are not as accurate at the upper altitudes, specifically in humidity. Contrail formation depends on temperature and humidity. And temperature is pretty well defined across the whole atmospheric column. Humidity is much harder to get a accurate estimate of at those higher altitudes. And so that makes predicting contrail formation and downstream climate impacts a lot harder.
I think it's really interesting to hear you say we see contrails as weather. Can we get a little bit of an overview? How exactly do contrails form? Which types of flights or aircraft are most likely to produce them? And how do they have an impact on global temperatures?
So contrails form as an aircraft flies through the atmosphere. It releases soot and water vapor as part of its exhaust. If the atmospheric temperature and humidity has the right conditions, the water vapor emitted by the aircraft and from the background atmosphere will condense around the soot particles that are emit from the aircraft. Again, if the conditions are just right, that droplet of water will eventually freeze and persist in the atmosphere as an ice cloud. So when we talk about contrails being weather, more that the atmosphere has the conditions such that contrails form and then persist and turn into a background cirrus cloud.
What are all the variables that make a short lived contrail versus a long lived contrail? Maybe we can discuss a little bit of that distinction as well.
So the main aircraft dependency has to do with the engine. So if the engine is emitting more soot at a different temperature, then it will interact with the background atmosphere differently. So the mixing will happen either to form those liquid droplets or not. So there's this well-known criterion, it's called the Schmidt-Appelman criterion. That determines whether any contrail will form, short-lived or long-lived. So whether that droplet freezes and persists in the atmosphere completely depends on what's called ice supersaturation. This means that the relative humidity of the atmosphere is above the saturation vapor pressure of ice. Another way to say it's really cold and the ice doesn't evaporate after it comes out of the contrail. So in general, when we talk about climate impacts, we don't care about short-lived contrails. They're seconds to minutes long. You'll often see these in the sky. The contrail is evaporating before the plane leaves your field of view. Sometimes it'll be minutes long, so the plane is gone, but it's just this linear feature that is ephemeral. We really care about the contrails that persist in these ice supersaturated regions and then eventually spread out to form something that has a radiative impact.
So it would almost be accurate to say the contrails that look like contrails to the naked eye are probably the contrails of least concern, and the ones that look like clouds or that have spread out to become clouds are the ones that we really care about.
Yeah, that's right. That's right. We often will talk about contrail outbreaks. So you'll see a whole bunch of linear features and then a hazy layer that has formed that wasn't there before. These regions will grow as more aircraft fly through them and expand their impact. You asked earlier about which specific aircrafts will form contrails or form more harmful contrails. Just in general, the older, less efficient engines will form more persistent contrails because they have higher soot emissions.
Yeah,
It gets more complicated as the soot emissions come way down because then background aerosols and other particulate matter coming out of the engine starts to become important. As you reduce the soot in the engine, you'll reduce the amount of contrail impacts.
and when you talk about background aerosols coming out of the engine, now you're hinting at a potential counteractive effect where some of those emissions are actually producing a slight cooling effect at the same time as the overall warming effect of the contrails.
So contrails can both be warming and cooling themselves. So ice clouds will reflect solar radiation as well as they'll absorb long wave radiation. The aircraft will also emit aerosols like sulfur dioxide, which they themselves only have a short wave reflecting capacity. So, yes, there are some small aerosol impacts that will have a net cooling effect, but they're much smaller than the ice cloud impacts.
Super fascinating and very nuanced. I want to move into how you've been able to apply some of this research to real world use cases. So maybe you can give us an overview. What are the efforts that your team and maybe others as well in your field have already taken to model out potential changes in order to effect contrail avoidance? And what are all of the different levers that we have on our kind of dashboard, so to speak, for that?
Yes, we'll often talk about this on the time scales of implementation. So, way ahead of your flight, you could theoretically plan aviation globally such that you're statistically less likely to fly through these regions of atmosphere that matter. So this would be flying less at night. It might be flying less in the wintertime. You can look at how contrail impacts are distributed on average across the globe and then plan accordingly. We could also improve engine technologies. So, engine and fuels, like I was just talking about, you could reduce soot and reduce the amount of contrail impacts overall. But that is a more expensive, longer implementation life cycle than something like navigational avoidance. So we often prioritize in our work first navigational avoidance, which would mean predict where you're going to form contrails, predict how those contrails have an impact on the climate, and then reroute aviation to avoid those regions however they can most efficiently avoid those harmful regions. That can be implemented today if we're confident that the models predicting their formation and impact are valid.
What are all the data inputs that feed into a system like that within the context of an existing commercial flight management system? Maybe give us a quick overview of what all is entailed within a commercial flight management system. And then within that, the things that we have control over and what are the pieces of information that we need to be able to make those decisions.
Yeah, so flight planning is surprisingly complicated, as you can imagine. And so the main input from our side is meteorology, so the weather forecast. Weather forecasts are run every 6 hours, generally speaking, and they predict the state of the atmosphere for every hour. So the flight planners will ingest weather forecasts that have the standard variables, temperature, pressure, humidity at every point in the atmosphere on every hour. And they will also ingest some higher order data variables like turbulence forecasts and icing, convective significant weather events. Those are built into a 4D optimization. An airline will come to the flight planner and they'll provide their schedule. They'll say, we want to fly from JFK to London at these times. Roughly 24 hours ahead of time, the first flight plan is made. So, flight planning happens actually much closer to the flight than most people realize. So, they'll make a notional flight plan maybe as far as a day of ahead of time, maybe 8 hours ahead of time. That flight plan will be revised 2 hours, 2 to 4 hours ahead of the flight. And then the plan will be filed, approved by the air traffic organization of the region. So they call these air navigation service providers, ANSPs. The ANSP will approve a flight plan. It'll go to the pilot, and then the pilot will try to fly that flight plan as closely as they can. So at each stage in that system, the flight planning stage, the air traffic management stage, and the pilot stage, the meteorology is getting input into that system in its most up to date form. At the end of the day, the pilot is allowed to fly whatever route is most safe for the plane. So if the pilot deems the flight plan incorrect, given the most up to date meteorological conditions or what they're hearing across the radio, they can choose to divert accordingly. So it's interesting, actually, as Wi Fi gets built into the cockpit, it actually really helps our cause because pilots that are crossing the oceans can get the most up to date weather hourly as it's getting predicted. The closer we can get to the meteorological forecast run, the more accurate we can actually be in predicting these regions. Other inputs for us are aircraft type and engine type, so the aircraft engine combinations. Models aren't, in the grand scheme of things, soot emissions is secondary to just avoiding the region of the atmosphere that matters. I think there's literature out there that would say reducing soot emissions or using sustainable fuels has a net warming impact or a net cooling impact on contrails. And so there's even more uncertainty on that discussion. But eventually we will figure that out. And being able to adjust the aircraft engine combination and the fuel, depending on the route and its contrail impacts, is an important lever that we'll have at our disposal. Mark Stetler's group wrote a really interesting paper in 2023 around the targeted use of sustainable aviation fuels. So it was a theoretical exercise saying, we predict that sustainable aviation fuel will overall reduce contrail impacts. So why don't we use our limited supply to target routes that have the most contrail impacts and that you can actually increase the utility of that finite sustainable aviation fuel by addressing both the carbon and the contrails?
In all of the discussions that I've heard or been a part of on sustainable aviation fuels, I have not heard this tie in, this very strategic picking and choosing, this selective application against the contrails problem so that you get that double benefit. And we'll talk about this a little bit later, but I think it speaks to the absence of contrails in the broader climate mitigation conversation, which is actually, I think, a huge problem. And just like very curious because it's, as you explain it, it's not really challenging to understand. It's an exciting area because it seems just very high impact, really efficient. So that's fascinating. This idea of, hey, we have limited SAF volumes, can we really use them to get as much benefit as possible? Mark, I just want to clarify something. You've been talking about navigation. And sometimes when people hear the word navigation, they think about, okay, are we going to go further left instead of further right? Or we're going to take this more circuitous route? But we're not talking about actually fundamentally changing the route of the aircraft, going back to that original research that inspired you to get involved with contrails that was looking at slight shifts in altitude, 2,000 feet up or down. Can you tell us a little bit more about that? What specific types of changes on the routing side would be an example of how you might mitigate contrails?
Yeah, it really depends. It's a cop out answer, but it depends on the type of area that you're trying to avoid. But realistically, we're trying not to tell the flight planning system how to route flights efficiently. Like the flight planning system is very good and will be getting better at optimizing a flight trajectory given constraints. And so they'll route below, above, left. In some cases, we saw completely different routings. So to contradict what you just said, actually, there's some cases where you might fly from JFK to Heathrow on a different track across the Atlantic because of the contrail impacts. And it doesn't change your flight time because the winds are a little different along that flight track. So maybe you have more wind at your back. And so you get there a little faster. In general, it doesn't cost any time to make these deviations, but it may cost a little bit of fuel because in general, airlines are trying to reduce their fuel as their optimal routing. So if we're deviating from whatever was the existing optimal, we're likely adding a little bit of fuel. We find that 10% of cases, 20% of cases, depending on the simulation, will be a no cost reroute. So that just means there's no added fuel, no added time. It's just one of the many options that the plane has to take. And so we see those as no brainer. Like you might as well just go for the contrail reduced route. But it is a minority of cases compared to the adding a nominal amount of fuel. That being said, when airlines plan flights, there's always 10 different options for the routes that they could take. And generally speaking, the flight planner will select a routing based on any number of business factors that they have in mind. And then again, the pilot will revise that depending on were they delayed or did a convective event start happening in a certain area that we need to go around. Zones will often really impact the routing system. And so when unfortunately the Ukraine war broke out, planes started having to spend an extra 4 hours to get from Europe to Asia. And it's obviously not the CO2 optimal route. And this kind of thing happens all the time.
It's fascinating to think about as much as we have data and automation in play within aviation, that so much of it is still down to real time decision making and the expertise of pilots and the people involved in the overall navigation stack. A while back, I remember seeing a company that was helping to incentivize ship captains within the maritime shipping industry to make small changes like reduce idling, slightly change their routes, things that were easily within their control to decrease fuel consumption. And they ran some pilots and found that they were able to significantly reduce, of course, fuel related emissions, but also just fuel related costs for shipping companies. And so shipping companies had a huge incentive to try to implement something like this. It was like a gamified version of route planning. I'm curious in bring that back to contrails. In the case of contrails, how much of this is going to rely on that sort of incentive structures for pilots, being aligned with what airlines want, being aligned with what policy is asking for, and what we need for climate stability, because it still will be down to a lot of human decision making. How do you get everybody on board?
That's a challenge. That's the main challenge of this topic. I think there's lots of really interesting scientific questions to ask, and we have to continue to work to reduce the uncertainty bars on both our ability to predict contrail formation and persistence and our ability to relate that to overall climate response. But in general, I would say we have an idea of how to predict contrail formation and persistence. We have a very viable implementation path to address that within the flight planning and air traffic management system. There is really no good solution or roadmap for how we get this adopted in the long term. And so the obvious uh, conclusion there would be some kind of regulation eventually will come into effect that says you can't fly through high impact regions of contrail formation. But we're not there yet, and we likely won't be there for a while. So in the intermediary, I think there's been a lot of very effective programs within airlines trying to incentivize pilots to reduce their CO2 emissions. Because obviously, for the same reasons that the maritime captains were incentivized to reduce fuel for their employers, it works. Like if you tell the pilots, we're going to give you a bonus if you keep your fuel under a certain amount, those have been really effective, but they're a little fraught because you don't want a pilot to be trying to save fuel at the expense of safety. So with aviation, safety is paramount. Any kind of incentive that gets developed has to consider safety as the primary and then climate benefits as the portfolio option after. I do think there is a opportunity to develop a creative incentive, but it will rely on airlines acknowledging this problem. So that's one thing that needs to happen to general understanding within the aviation ecosystem. And then I think the consumer base also has to understand the problem because, in general, the aviation industry right now is incentivized to work on climate primarily because that's what its customers are asking for. In the long term, like I said, regulation is the way to do this comprehensively. But in the short term, I think we need to elevate the understanding around this problem, demonstrate that there's a solution that's available. It needs work because there's a lot of challenges associated with it, like we said, uncertainty, and then also in practice, what happens when all aircraft are trying to avoid certain pockets of airspace. So there's some operational considerations that still need to be worked out. But it'll be really interesting to see how this evolves over the next few years because I do think there's space for incentives to be developed that sort of acknowledges contrails on the same level playing field as CO2.
Yeah, it's interesting because given Contrails' connection to, atmospheric science, its grounding in atmospheric science and how complex that field is, it just really doesn't lend itself well to memification.
Yeah.
And I think your point about public understanding and, sure, corporations drive emissions and they drive a lot of behavior change, but what drives their behavior change? And at the end of the day, it's the social license. And then that is driven by education and awareness. And where do we start in systems change? It's such a fascinating thing to ponder. And what I always come to is we have to do everything everywhere all at once. Like we just have to do all of the things. And whatever tool we have at our own disposal, whether we have been doing applied sciences and geospatial data as you have, and you're just like the perfect fit for something like this, or whether we have storytelling abilities or whether we can, move capital or whatever it is, we just have to start where we're at. But I do think that's an interesting challenge because prior to your research being written up in the New York Times, MIT Technology Review, and a few other spots this last month, I have not once seen a mention of contrails related warming or contrails mitigation in any mainstream media or even standard discussions about climate. The only conversations I personally have had about contrails is with our mutual friend Brian Ames, who introduced me to you and who got me on the contrails bandwagon himself because he does a lot of deep research into areas of immediate and like major climate impact. And just the fact that I work as a climate investor, I talk to people who think and do and build climate related solutions all the live long day. And it has not come up across all these years. So I think that's really shocking. And I do think your point about shaping incentives and how we do that and how that's challenging is a great one. In the example with the maritime captains, so they actually tested offering them a bonus versus offering them the ability to donate a pretty significant motivating sum to a charity of their choice and found that the latter option, the donation option, was much more powerful of an incentive in driving adherence. So I think that's really interesting too, is like asking ourselves, what gets people to do something that is otherwise an unsung and invisible act? And now the unsung and invisible part is going to bring me to another point, which is all around MRV, measurement, reporting, and verification. We struggle plenty enough already with MRV, with measuring and verifying and reporting on carbon removal, which is a much better established space than contrails mitigation. Can you just give us the lay of the land for MRB on contrails? Like, how would we actually go about measuring contrails reduction, proving that measurement, and then incorporating it into some sort of reporting schema that would enable airlines and then all the way down to pilots and potentially buyers within some sort of marketplace to take credit for that work?
Yeah, that's a big question. You may have seen that the European Union, they have a sort of proto MRV scheme for non CO2 that just passed in the last few weeks. So Part of what I'll say here is a reflection of what is being done but I can also share some ways that I see this going in the future. So in general, right now, the only way to do flight by flight estimates is to use models. And that would be to say, does this aircraft form a contrail? How long does that contrail live? And what is the radiative impacts over the contrail's lifetime? There are also ways to observe contrail formation. The group from Google has worked with a team at MIT to really pioneer some deep learning techniques around satellite imagery that allows you to detect individual contrails and then watch them as they evolve in time for the at least for the first hour or two. And what's been really nice about those techniques is it's an independent of the physics verification. And so we can compare the statistics over time and space and make sure that in general the models are agreeing with what we're observing. Um, and I'll say that in general, the statistics do agree. I'll share one small anecdote on that. In our modeling, we saw a real lack of contrails over Oceania. We were approached by some Australian airlines that wanted to do some work. And we were surprised by that and thought our modeling must be wrong. Um, but we approached the Google team and asked them for their statistics over the same region, and they lined up perfectly. So, because of larger circulations in the atmosphere, there's this relatively dry section of the Earth where contrails just don't form that often. And so, it's the observations provide a really nice validation source for kind of the overall statistics. So now MRV is tough because you want to know, did my aircraft form a contrail and how much radiative impact on the climate did that contrail have? And I think in general, we're never going to get a satisfying one to one. This flight formed this many CO2 equivalent warming metrics. So what I would propose to that end is essentially we have these regions of airspace that the models suggest we should avoid, and those regions have a severity associated with them. You could even imagine this like a Richter scale, and that airlines are tracked based on how many kilometers of contrail they're forming in those regions. And that we can do from the satellite. So you can independently verify contrail formation flight by flight. And then you could link that back to some portfolio standard around, okay, you're allowed to fly this many kilometers through high severity contrail regions, but you have to keep that to 20% of your overall contrail portfolio. The way the European Union is doing it to start is allowing the airlines to bring whatever contrail model they deem best forward and allowing them to self-report their contrail impacts for their network of flights. Those will be compared with the available observations that we have to develop the next level of MRV into the future.
What do you think about that? What do you think about airlines bringing their own models now with higher resolution Earth observation? But should there be a unified standard? We had in our notes here that Gold Standard is actually developing a contrail related offset product, but I think that's fascinating. What is that world going to look like? Are we going to have just this wild west of contrails claims? Are we going to have contrails trading? Are we just getting way too far from the goal with even thinking about that stuff?
What I think is really valuable about the existing MRV scheme is that it's bringing attention to the topic and it's enabling the airlines or forcing the airlines, depending on which side you're looking from, to have to quantify what their impacts are. And so at this point, when there's no carrot or stick for mitigating contrails, we're starting to build literacy around what are the impacts of my network or estimated impacts of my network, which routes are the most harmful, and what time of day do those routes leave at. So you can building a database of all aviation climate contrail impacts will be really helpful to just understanding the problem better and then being able to discuss it with the airlines. I think it's a little too early to say if this follows a carbon trading future where one airline will trade its contrails for another. I find that pretty hard to believe right now. I think it will be more like airlines may be paid to avoid contrails if it's verifiable. So some kind of scheme where corporate buyers are trying to minimize their scope 3 emissions. And so contrails become part of that. And incentives are passed along to the airlines to actually implement the avoidance rather than one airline trading to another.
Yeah, I'm sure about the recent acquisition of Citavia by GM Aerospace. So it was a startup that was doing contrails methodologies and contrails avoidance tech. I'm curious of what you do think at this early stage about commercialization. You came into this originally because you thought, "Hey, we're ready for commercialization now." And then found yourself in this sort of research science role for now several years and counting. What are your thoughts today on how far off are we on commercialization? What might some of those models look like?
Yeah, that's a really good question. I think the goal of our project for the last few years has been to establish a baseline for contrail impacts and provide the tools to the industry such that they could start building around it. The hypothesis is we're going to get better at predicting these regions to avoid. Let's build the capability now because aviation has such a high standard for safety. Let's build it in there now, test it out now, and use that to actually advance the science faster. Because, like you said, this is one of the only climate opportunities that's actionable next year if we had great models. And I think that on the commercial side, there's absolutely a lot of commercial opportunity in the delivery of those services to the airlines. So, imagining there are plenty of startups in the flight planning space and also flight planning support space. There's a startup in Europe called Estuaire that's doing data services for airlines that includes the outputs from our contrail modeling that are open source. So again, building that literacy with the airlines. Yes, Satavia was a really interesting startup. They were trying to, what you'd say, vertically integrate all of Contrails into one service. So as an airline would be able to check a box and start doing contrail optimizations within their own outside of their planning services. And I think in general, they were just a little bit early. I could see that model really working. It's a little bit of the west right now that we're at least all heading in the same direction. And I see our role really trying to help establish that baseline right now.
And just to be clear, when we talk about whether it's Estuary, Satavia, any kind of commercial applications built on top of the body of research that you and your team and others are working on, we're talking about software solutions. Like they would essentially be or look or behave like software solutions. We're not talking about building gigantic infrastructure projects.
Yeah, that's what's amazing about it links back to your first question of the discussion. This is just a checkbox in a air traffic management software. When this is all done, nobody should even know it's happening. It'll just be automatically happening. We'll be flying smarter. That's another thing that I really like about working on this topic is just the fact that if we didn't need to build public awareness around the topic to incentivize action, really no one would ever have to know that this was happening. It would just be another criterion in the optimization.
Yeah, in many ways, it's an all gain, no pain or very little pain. There's a potential for a small increase in fuel consumption and the associated long term warming, but the short term cooling benefits is so enormous that it far outweighs that. And we know as we get so close to planetary boundaries and various tipping points that anything we can do to reduce short term warming actually has all of these potential knock on effects in terms of walking us back from the edge of the greatest risk. So that's a fascinating point to consider when we think about trade-offs. Do you and your team talk about trade-offs at all, or is this sort of so obvious that it's not part of any discussions? How much does this really come up in conversations that you have either internally or with other stakeholders around aviation's overall climate impact and the sum total of it.
We talk about trade-offs all the time. That's the Achilles heel of the topic is if this were free, then we could just start doing it and learning as we go, and we would steadily improve over time. I think our our caution and hesitance is around we want to be really sure that what we're doing is helpful. And obviously, we don't want to add fuel to the system and either not have any impact or potentially even worse, inadvertently cause more harm by making this intervention. All that being said, we haven't seen evidence yet that we're heading in the wrong direction. I've always said that if we start to see evidence that these interventions are harmful overall, we'll absolutely not encourage everyone to do them. The study you referenced was astounding that any individual intervention is roughly 1% of added fuel, like on average. And you could even set that as a hard limit as an airline. You could say, look, I'm only willing to bet an added percent of fuel on this route to avoid contrails. And for that 1% of fuel on only 5% of flights, so we're talking about a much smaller percentage over your whole network, you're potentially gaining back all of the warming from all of the emitted CO2 since the dawn of aviation. So the lever is huge. Another way to put this is 1% of the global aviation fuel usage is roughly zero point zero 0.01 millikelvins per year of warming as it adds up. And the potential benefit of contrail reduction, if we're able to get rid of contrail warming and hold it, avoid it. So this is an active intervention. You have to keep avoiding the contrails all the time. That's like a 10 millikelvin benefit. And so it would take about 1,000 years for that cost to outweigh the benefit. So again, this the trade-off question really comes down to a societal values judgment. It's a timelines question. We talk about it makes the work hard. I think it's also what makes it exciting. It's like we have to wrestle with the trade-off in order to make sure that we're doing something that's helpful.
It's makes me think of once upon a time we put lead in gasoline and then we realized it wasn't good to put lead in gasoline and now it's not normal to do that. And we've just changed the practice. And while we still have gasoline, we're still driving cars with internal combustion engines. None of those cars are also emitting lead. And it strikes me that this is or has the potential to be just the normal way that we do things, checkbox, as you said. However, there does seem to be an opportunity to engage the consumer public around this, just as now when you search for flights on Google Flights or sometimes with in other OTAs or flight search engines, it'll show you the estimated emissions for a flight. I don't know how much that actually figures into decision making, just as nutrition facts still don't figure into much of food decision making. But regulations, at least in food, have made them ubiquitous. And I wonder if that kind of public sector influence might have a role here in making flight labeling something that we would see much more commonly. And then whether contrails or non CO2 emissions, non CO2 related warming might make it into some of that labeling and how that could change things. Have you had any of those discussions on what the public role could be separate from hardcore regulation around contrails avoidance? What are some of the other things what that whole suite of government intervention could look like?
Yeah, so luckily we work really closely with the team at Google Research, and they are connected to the Google Flights team and what they call the travel impact model, which is the open source modeling that powers those CO2 estimates on Google Flights. I think at some point soon we'll see average contrail impacts getting back into the travel impact model and then eventually percolating its way back into the kayak.com and Google Flights flight aggregators. It's tough though, because that will only be a statistical estimate. It'll be about as good as saying, okay, if you fly eastbound across the Atlantic and you leave at 9 p.m., it's going to be more severe than if you leave at 8 a.m. on average. it's pretty hard to believe that an actual predictive meteorological forecast is going to build its way back into the consumer facing products. But the way we see this is that retrospectively could be just as powerful. So we're building a database of all global flights and their estimated contrail impacts based on the modeling. And then the team from Google is helping us add columns for verification. This flight had a verified contrail length. And then we'll be able to do some more data science work around the validation schemes and how we might best go about addressing this heuristically. So that's one kind of consumer facing data product that we envision in the next year or two. You may have come across our Contrail map. That's one of my favorite things we've done on this project so far. The Contrail map just visualizes global aviation and the estimated contrail impacts from all of those flights. I think that is a way that I envision consumers going on the contrail map and asking, did my flight produce a contrail? And can I see the satellite imagery to compare for myself to see that contrail overlaid on the modeling? And in general, that's only encouraged the confidence I have in the modeling. There's certainly inaccuracies in the modeling, but in general, the qualitatively the satellite observations line up with the contrail outbreak regions. So I do think we see the most benefit likely coming from the business traveler community. So corporate policies saying, okay, here's what our contrail impacts were last year overall. We'd like to reduce that. And so we're going to restrict certain routes. And that would knock on to the airlines because they respond most closely to their business traveler community. But again, that's all averages. It's not the actual forecast that represents the real time.
And the Contrails map is map.contrails.org. Really
Yes.
cool, beautiful graphics, interactive, impressive amount of data and computing that go into that. I want to zoom out and the role that normalizing contrails awareness would have on having corporates like McKinsey or Google or any organization that has a lot of business travel say start to actually include that in their annual report or in their sustainability report, the way they do, the way they talk about their zero waste strategy, their water usage, their energy related emissions. And so much of that has to do with tying contrails to the broader climate discussion. I'm curious that we've been very focused on your work and how it relates to contrails and how contrails relates to warming. But are there other areas of climate science or are there other climate interventions that could also be supported by the research that you're doing, separate from simply contrails related non CO2 warming reductions? What future directions could you potentially see coming from the work that you're doing now?
Yeah, it's a good question. I see the larger topic that we're working on as cloud microphysics and cloud evolution, aerosol cloud interactions. So the fact that the aerosols emitted mostly by the northern hemisphere contribute up to 50% of the cloud cover at any given time is largely not understood by the scientific community. And the error bars in the climate change discussion are vast. So I think our small, very targeted research group is really contributing to a much larger body around how do clouds evolve? How do aerosols contribute to cloud formation and evolution? And getting a better handle on how even just cloud detection, optical properties, and modeling might be a really helpful outcome of a lot of the work that we're doing, or at least a helpful extension of the work that we're doing. When I consider the observational resources that would be useful for contrails, I get the most positive responses from the science community that's interested in cloud observation. Just an example that comes to mind, I'm sure you've heard of marine desulfurization, the WMO regulation. In a lot of ways, it's got many allegories to the topic that we're working on because the WMO researched sulfur in marine fuels and recognized adverse health effects. And they, in the stroke of a pen, basically regulated it away within a certain distance from the shore. And it costs the shipping industry tens of billions of dollars to adhere to those new regulations. And yet adoption was immediate and almost comprehensive. When that happened, there was potential effects on the cloud formation over ship tracks because sulfur and diesel fuels were contributing to forming clouds as ships were going across the ocean. It's a really interesting topic. I don't have a strong opinion. I haven't researched it myself very closely. But if we had better cloud observing networks, we would be able to answer the question of what impact that marine desulfurization had on cloud formation and resulting radiative forcing. And I think that you'll find in the literature people arguing for both sides, either marine desulfurization had no impact on the climate, or actually marine desulfurization had a huge impact on the climate. And I think the missing link there is just a really dense network of cloud observations.
Yeah, amazing how much we still don't know about clouds and how important clouds actually are, it turns out, to the felt effects of atmospheric temperature changes, as well as just moisture, extreme weather, storms, all of these kind of very real world on the ground things that we experience. I've seen stuff that linked marine desulfurization with the temperature jump that we experienced mid 2023 onwards. And I don't know if that's on the further end of your range of people claiming, oh, it had this huge impact, but it
Yeah.
certainly aligned with what we experienced as people all around the world during that time, right? So it's made sense. And that even made it into mainstream conversations with non climate people in my life. So I thought that was actually really impressive. And it shows how fast things can really change in terms of public awareness and discussion if media catches on to something and then sort of it just enters, it makes sense for people right away and it becomes a cocktail party discussion topic, which is what we hope contrails will be actually.
Yeah, you're
So
helping here. Just one way that another thing I really like about working on this topic is that it allows us to talk about climate change in a much more base form. We often equate CO2 emissions with all of climate change, but it's really about two-thirds of anthropogenic radiative forcing. And with contrails, you have to talk about radiative forcing. It's affecting the climate balance through a similar but very different mechanism than CO2. And I just like the topic because you have to wrestle with how the climate is changing and how humans have impacts on it. So sorry, it's a digression, but I think that's an exciting part of working on this topic in particular.
it makes it really rational, right? It's we can feel the radiative forcing, or it has felt impacts, and then it takes or it almost depoliticizes it a bit and takes it away from this emissions question, which really quickly gets into a finger pointing and a discussion of different interventions on emissions specifically, and who all is responsible for them. So I do see what you're saying, and I think that kind of brings us all to a more fundamental, basic building blocks of warming level of the discussion where if the general public had more of that knowledge, and this is more around our overall understanding of science and earth sciences in particular and how lacking it is and how misreported it is as well. But that would really be a different world. Okay, so with that, I want to just wrap up with a very fast lightning round of questions. So don't think too hard about these questions. Let's try to just jam through these really fast, short, punchy, and would love to hear what you think on just a couple of popcorn topics that we didn't get a chance to cover. So, firstly, what has been the most surprising finding in your contrails research?
That the amount of added fuel is basically zero.
Very exciting. What's been the most significant barrier to widespread adoption of mitigation strategies on contrails?
Same answer, because the added fuel is not zero.
It's
Because there
almost,
is a
but
trade
not
off.
quite zero because of the trade offs.
Yeah.
If you could implement one change in the aviation industry today, what would it be?
It's free routing. So allowing airspace to be unrestricted so that you can fly wherever it's most climate optimal. You could see a 10% reduction in CO2 emissions if you just allowed planes to fly unrestricted.
Wow. Which emerging technology do you think would have the biggest impact on aviation by 2030?
Free airspace routing in flight planning.
What's your favorite climate solution outside of the aviation sector?
Oh, that's a good synthetic food movement or synthetic food and then also fermented food movement where we're starting to synthesize molecules directly from carbon, whether it's captured or otherwise, into edible molecules.
How do you see AI contributing to climate science, whether that's within an area that you're familiar with or beyond it in the next decade?
I think it'll allow us to make decisions a lot quicker based on very complex systems.
If you had unlimited funding for one single research project, what would it focus on?
I would launch satellites to observe the atmosphere at very high resolution globally across all time.
What role do you see for startups in the future of contrails management?
I see them delivering forecasts to airlines and flight planners and air traffic managers. And I see them providing data services from flight data, contrail observation data to help verify those forecasts or support those forecasts.
And last question for you, Mark. You've been in applied sciences and applied earth sciences for a while. You're part of Breakthrough Energy. You are immersed in climate world. What gives you hope in the face of the climate crisis? It can be a heavy space to work in. What gives you hope?
Um, I think there are an incredible number of people that are passionately working on the topic. That gives me some hope. And I also think that climate investments are starting to become viable. And at the end of the day, that's what's really going to make a difference. And so I'm hopeful that the BEV portfolio can demonstrate an enormous return to its LPs and that we see climate as the next uh, major investment vehicle accelerating technological progress.
Awesome. On that note, and cheers to that as a fellow climate investor. Thank you so much, Mark. This was incredible. We'll share all of your URLs and different things and links to your research in our show notes. We've had such an amazing time getting to chat with you today, learned so much. Hope to have you on again when you have your next iteration to share with the world. And thanks again for everything that you are out there doing and contributing to the broader body of global work, but also just sharing your day with us, saying hello from Vermont and telling us a little bit about the little known but soon to be blown up world of contrails.
Thanks for inviting me on. I'm very grateful to be here.
Thanks for listening to Climate on the Edge. If you liked this episode, please subscribe to the show and consider dropping us a 5-star rating and review. You can also follow us on social media so you never miss an update. Climate on the Edge is brought to you by Emergence, innovative minds exploring climate's next frontier. Thanks again for tuning in. See you next time.